Fresh on you. Just saying. Okay, angle relationships. I don't know why my circle is so ginormous. You don't need to draw this circle. I just wanted to review what we talked about yesterday before we go on. If your computers are out, either close them or face them towards me. Well, because you have your other side, right? So you can just staple them when you bring your backpack tomorrow. So either shut your computer or turn it towards me. Either shut it or turn it towards me. I know. Okay. The angle relationship, we already covered one yesterday. So does anyone remember what this angle is called when it touches right here on the circle? They're called inscribed, like in sync, but not really. Inscribed angle. And then we've got this intercepted arc that it makes. So if I tell you that this arc is 120 degrees, Ethan, what would be this angle? That's a good question. Is it 120 or is it 60? Because we covered two different types of angles, and sometimes it's equal and sometimes it's half. You remember, Kate? What is it? 60. Inscribed angles are half. If it was a central angle, we'll see if I can draw it. Wow, that's not very good, because that looks like 180. If it's a central angle, it would be equal. If it's an inscribed angle, it's half. Yes?
Why is it half? If the angle's not getting wider or shorter, it's just like close together.
Because it is getting wider and shorter. Okay, two more things to review. Martha, how much is it to go all the way around a circle? How many degrees? What are you asking? Oh, like the chord from here to here?
Okay, just move on.
Making it more confused.
The whole thing around is free. That's just how it goes.
Oh, okay. If you were to take, have you ever had those protractors that you actually measure the angles? Okay. So when you take the central angle, first of all, look how wide it is. It's huge. It's bigger than 180. So if I'm measuring that with my protractor, it's going to be, what have you decided, 120 degrees. If you measured this one, it would be 60 degrees. So when we talk about the measure of this arc, it's not the length. It's not taking a measuring tape and starting here and measuring it all the way around. That's not what it is. I think that's kind of what you're saying. When you talk about the measure of arc, let's name it like BC. It's reflecting the angle. That's all it is. It's reflecting this angle measurement. It's not actually talking about the distance from here to here. Is that what you mean? Okay. I know that bugged me too. So we will, when we start talking about the length of it, it'll be part of the circumference. But as of now, it's just reflecting the central angle. And so to reflect it, to help us find the inscribed angle, you do take half of the measure. Don't think of measure and length as the same thing. I know, I'm stunned about it too. Okay, all the way around, I don't know if Martha said it. 360 is all the way around. If we take a diameter and we make an arc, what is the measure of that one, Jose? 180. The book expects that you know these things. Okay. I like his questions. They're good. Okay, so as a quick review from yesterday, we're going to go kind of fast. Everyone look here at this picture. It wants the measure of arc BC. Logan, how do I find it? So what is arc AB? Because it's twice, so what would BC be? Okay, since this is a diameter, we know the total is 180. So some of them took 2 steps. Okay, let's look at the next one. They want us to find the measure of angle P, but of course they did not tell us the arc. Sydney, how would I find the measure of that angle? Has anyone done that already? Yeah, because we don't know if this is a diameter, so we have to go with what we do know. We do know the whole thing is 360. 148. And then Sydney, what do we do from there? Half of it. Okay, let's look at the last one. Something about these was a little confusing. We went on to a different theorem where it talked about how two inscribed angles shared the same endpoints. So if I start at the endpoints and follow it up, I've got, ooh, I thought that I was on pencil. I've got angle G and angle F. They have to be the same measure. Or you can go the opposite way. So you could start at these endpoints and follow them down to angle H, follow it down to angle E. So Lindy, after all that, what's the measure of arc EH? It definitely matches with 42. But since it's not a central angle, how do I find the measure of it? Double it. Okay. The one from the homework that the most people got stuck on, I think, was this. They were asking neighbors, they were copying each other's answers. It was kind of a disaster. So let's just walk through it together because we do have a test next Friday. I want to make sure if you see something like this, you can feel confident with it. So Tate, how would you find A and B? Because A, if I look at this inscribed angle, if I look at that inscribed angle, just a sec, this is my intercepted arc, but I don't even know part of that. And if I look at this angle, which this is going to help me find B, if I look at this angle and its inscribed or intercepted arc, I don't know JK. I kind of need to know JK. Do you agree? Bradley, how do you find JK?
First, all the stuff is somewhat. Second one, you just take 360, take all this.
Take 360, subtract 54, 130, and 110. I helped so many people with this. I actually have memorized what that is. It's so useful. Okay, once you have that written down, let's go back. Let's just find the whole angle. Let's not worry about A yet. Let's just find the whole entire angle. Yeah. Yeah, what's 54 plus 66? So what's the whole angle going to be? Some people, yes. Yes, so the whole angle is 60 degrees. Some people were taking 120, dividing it by 3, and wondering why they were getting the wrong answer, because we were skipping that step. So take the arc, cut it in half, then divide by 3. That's a 2. It's a really bad 2, but that's a 2. Okay. Now we got to find B. So before we find B, let's find the whole entire angle. It was so hard. Half of you guys have the answer memorized. Interesting. Paxton, how do I start this out? So I want to find this whole angle. How do I find this arc? Okay. Divide by 2. Is anyone doing that in their head? Is it 88? Did I make that up? So again, a lot of people were forgetting to do half of that. They were really concerned about the 4. So all their answers were twice what they should have been. Okay, then we can divide by 4, and B is 22 degrees. Okay. Just enough people were copying each other, or, this was just stressing everyone out. I wanted to make sure we know how to do it. So find the 66, and you kind of have to ignore pieces of it. You have to be able to ignore parts that you don't need. Okay. So that just took a lot of time with my last class, so we're skipping it. Yeah. All right. Macy, will you read our essential question?
When a chord intersects a tangent line or another chord, what relationship exists among the angles and arcs?
Chord, tangent. I think we all know what those are from the bell work yesterday. I think we all know what arcs are. So we're not learning any new vocabulary today. We're just practicing what they do to the circles. Okay, here's our first theorem. We are on the back. We're on the top left. Please begin writing immediately. If a tangent and a chord intersect at a point on a circle, that's important. So a tangent and a chord on a circle. True. Dead boring. Put people to sleep. If a tangent and a chord intersect at a point on a circle. And the pictures and the equations, like this might even be more helpful than all the words for some of you. Then the measure of each angle formed is half the measure of the intercepted arc. Half the measure. You can go right now if you want. So I don't know about you guys, but the picture and those formulas are more important to me than all the words. The words are good to have. But if you get tired after the words, maybe start with the picture. Okay. We have a tangent. It touches it once. We have a chord. This chord could go anywhere. It could even be the diameter. But it's inside that circle. So yes, we have those two things. And then the measure of each angle formed. That makes it sound like there's more than one angle. Do you guys agree? And I like how they label them angle 1 and angle 2. So you can see exactly what they're talking about. Okay, so it's half of the arc that it's formed. So this arc here, if this is 90, what would be the measure of angle 1? 45, it would be half of that, yeah.
So if there was an arc right here of 90, and there's the diameter right down, would that ever happen, or would both sides have to be 180?
Both sides would have to be the 180, yeah. Okay, so we know that this is 45. I don't know if I can fit this in here. How can I find the measure of angle 2? Ashlyn, can you tell? So the measure of angle 1 we decided was 45 because it's half the arc. How could I find that angle? Oh, you could go that way, yes. She said subtract the 90 from 360. Is it 270? And then half of it. Did anyone see another way to do it? Yeah. Yes, so I see these two supplementary angles. So if you don't remember that a linear pair is 180, you could add that in your notes. Because if I am given one measurement, I can find this, I can find that, I can find this one. They're really connected on these ones, which is kind of fun. Is that right, 135? Okay, there's one example. Any questions on this? I think the weirdest thing is I know the formula says half. So if they give you the angle and you're finding the arc, you've got to double it. It's not just halving whatever they give you. So if it's backwards, it's twice. If it's back in, it's half. Twice, half. Twice, half. Was anyone not done writing that? Okay. All right, here's some quick examples. So think about half, twice. Half, twice. Okay, Ambrose, let's look at A. And they want you to find, they tell us that line M is the tangent. That's super important, apparently. Here's the tangent. Ambrose, how can we find the measure of angle 1? Which is anyone good at doing that in their head? 65 degrees. Let's look at the next one. Porter, on this one, they want us to find the arc. Well, how would I find it? Double it. Okay, so sometimes I'm sure on the homework, they'll give you that angle and they'll ask for this arc. Sarah, if they give me this angle, but they ask for arc KL, how would you find it? Yeah, it would be a two-step problem. So double, subtract, or subtract, double. Okay, 3 more. We're going to do these kind of fast. I was not going in very good order. So Jeremy, measure of angle 1, half of 210. Good. What else did I skip? Lindy, have I called on you? Yes. Have I called on you? Miles, have I called on you? We were like looking through each other. Okay, Miles, number 2. The measure of RST. Am I halving or doubling? I'm doubling. What's 98 times 2? I like Carrie. Okay. This one's a little bit more difficult. Not much. I don't think any of these are hard. The measure of x, y. Lauren, how can I find that one? I think there's definitely 2 ways to find it. She's doubling 180. Or you could find, So either way, I could subtract this from 360, or you can find the missing angle and double it. You're like, I'm done. I found it. 100. Okay. Any questions on this theorem? A tangent and a chord. But it's the same rule as the inscribed angles that we did yesterday. Half. Okay, you don't need to write this down. Not this part. We'll write something down in a minute. Paige, will you read the words up here for us? Okay, yesterday we did on the circle. The next 2 we're going to cover are inside the circle and outside the circle. So we know that these are half or double. The inside and outside are similar, but it's not just half. There's a little more work. So I'll read this. If 2 chords intersect inside the circle, that is important. I underlined it. Then the measure of each angle, they've got a couple of them labeled, is 1/2 the sum of the measures of the arcs intercepted by the angles and its vertical angle. It gets really wordy right there. The picture is so helpful. So I'll give you some time to write that down. I'll slide it up a little in case you want to get started on the next one. If 2 chords intersect inside a circle. Where'd your paper go? No, your notes one. Your notes one. Oh. I'll just give you the back. I'll just give you the back so you can just staple them together once you, but I don't want you to be behind on 4 more. If you write very fast and you're doing the one at the bottom, I did not have room to draw all 3 of those pictures, so I'll show you in a minute which one I drew. I think most of you are done with the top one. So 2 chords, check. They intersect inside the circle, check. Then the measure of each angle. Why is it only labeling 2 angles? Why didn't it label 1, 2, 3, 4? Sarah? Yep, so I like that this is up here. I can keep referring to it. If I find the measure of angle 2, this is also the same thing. They're vertical angles. And if I find the measure of angle 1, I've also found this one. They are congruent. They're the same measure in a different location. So I don't want those angles to feel left out. Now, this part, when you read it, gets really confusing, in my opinion. So then the measure of each angle, so let's focus on 1, is half the sum of the measures of the arcs intercepted by the angles, blah, blah, blah. Holy smokes. So if I'm looking at angle 1, basically what it's saying is it's created arc DC and arc AB. So I add them together, divide it by 2. It'll give you that angle. So obviously that's the same thing if I'm focused on these 2. Here, if I add AD, the measure of that arc, plus BC, the measure of that arc, divide it by 2, or take half of it, it'll give me those other vertical angles. So let's say this is, I don't even know if I can make up good numbers, 70 and 40. If those are 70 and 40, Levi, how could I find the measure of angle 1? Yes. Is it 55? Whatever. My answer here is not important. I just wanted you to kind of see how that works. Because I think these words get confusing, so I like that. That is not confusing to me. I can see where the arcs are. I can see they were created by these vertical angles. Hey. Yes. All right, any questions on that one? All right. This is the same idea, but the 2 segments are going to be intersecting outside the circle. So it says a tangent and a secant, which is this picture, 2 tangents, which is this picture, or 2 secants, which is this picture. This is the only one I drew. I had to pick one. I did not have room for all three. So this is the one I drew. If you also don't have room for all three, I don't care which one you pick. I just thought this one kind of encompassed both ideas. So this one's kind of cool. They intersect outside the circle, and the measures of the arcs are half the difference. So difference means to subtract. If you read this definition and you didn't know that difference meant to subtract, maybe swap it out for the word subtract or subtraction. A tangent and a secant. Two tangents or a secant or two secants intersect outside a circle, then the measure of this angle formed, then the measure of this angle formed, then the measure of this angle formed is half the difference. Would anyone ever have come up with this? I want to know the mathematicians who found these theorems. Wow, you love theorems, don't you? This is how much you love theorems. It looks like my ring. If I have my arms folded or I'm sitting on it, that's what, like the circle, except the middle of the diamond, like, I don't know. Oh, you guys are trying to fit all three pictures. Make sure you write the formulas and put the A, B, C at least around one of them, because that's the part that will help you. Like just choose one, put the W, X, Y, and Z, and put that formula in there. That'll make more sense than just your picture. You'll be like, am I adding? Am I subtracting? Am I taking half? Okay. You're going to see three different kinds that can intersect outside the circle. And you can see that when they first touch the circle, there's kind of a smaller arc. And then where they exit the circle, there's a bigger one. Same idea here. Where it first touches, it's this smaller arc. Where they exit, it's the bigger one. Where I first enter, it's a smaller arc. Where I exit, it's the bigger one. So the only thing I would say, which is going to be self-explanatory if they give you numbers, take the big number and subtract the smaller one, right? But you'll see in a minute, sometimes they don't give you the numbers, it's variables. So if this is, again, I don't even know real good numbers. If this is 150 and this arc is 40 degrees, how could I find the measure of angle 3? Yep, subtract the 2. Oh, did I do the exact same numbers last time? It's 55 again. I just made those up. Yeah, that was definitely not good numbers that I picked. Okay, once again, if I move on and you're not quite done, you just come and get my paper off my desk and you can finish them out. Okay. Okay, we're going to do these two. CJ, number 4, find the value of y. How are you going to find the value of y? First question, which theorem? Are they intersecting in the circle, on the circle, or outside the circle? So that'll zone you in on the formula you're using. So what do we do? Hope you're all thinking of this. So this angle is 102, but they gave us these arcs. How about you start to figure this guy out? So you can see we have these rules. It's half of the sum. Tyson, what do you think? How would you get started on this? We don't even want these arcs. We want that arc. I wish it was that easy. Not quite. So the one part I do know is I'm going to do 95 plus y and a half, right? That's how I can find this angle. But I kind of need to know it because I don't know y either. Tyler, how can I find this angle? How do I find it? These are vertical angles, so they're both 102. What are these ones, though? They're adjacent. They're 180. You could use 360. So, yeah, Paxton. No, what are you thinking? We've got all kinds of stuff going on. Yes. Yes. These are a linear pair. Yes, these are a linear pair. So you take your 180 minus 102. Bradley, what is it? 78? Bradley, you better check my work here. He always is one step ahead of my subtracting. Yes?
So why aren't the 95?
These are vertical angles, but on this one, this is not a central angle. It's not necessarily, like maybe the center of the circle is right here. So that's why this is not 95, is it's not, the vertex isn't on the center.
So why did you make the 102 vertical?
Those are vertical. I was just trying to get someone to realize how to find that one. That really doesn't matter for the problem.
So why is it 95?
In order for this angle to be 95, it would have to be a central angle. And although they're crossing in the circle, it's not the middle. So now I've got to use this other formula. 102.
She's sorry.
No, because the angles can be the same as you shifted them. Right?
Yes.
No, 95 is the arc, and 78 is the angle.
Yes.
That's why it's not
Congruent. So this arc is not equal to that angle.
That's why it's kind of congruent.
Tell me your question again.
Why is 95 not?
Why are these two not the same? Is that what you're asking?
So why is 102 the other side vertical angle, but not the 95? 95 isn't an angle. 95 is an arc.
Yes.
Oh, sorry.
It's okay.
And the 102 is the
Okay. I didn't realize that part would be hard. I think the hardest part of this one is we had to find the 78, which Paxton helps us with. So once I have this set up, I can use my formula. My lines are crossing in the middle. So this arc plus this arc divided by 2 is going to give me 78. I need to find y. So everyone look up, how in the world do I solve for y? You could distribute, but we're going to have ugly numbers. So I'm going to remind you guys of something that you can do. I don't want to distribute. Then I have fractions everywhere. I want to divide both sides by a half.
Why not x?
It's not an X, it's 95.
Maybe it is my next.
Double.
I just
What?
You broke down the
you did
equation, you broke
9x plus y.
9x, not 95. Oh. I'm like, no, I didn't. Okay, I did. When you divide by a half, it doubles it. I know that looks weird, but if you do 78 divided by a half, it's going to double it. Subtract the 95.
I'm ready for
You're ready to do these on your own? What's it going to be? Somebody better be checking me here.
It's 61.
It is. Okay, let's go back over this one again. In the theorem that we just practiced, it would be a lot easier if they were just asking for the angles. Because we add them together, we add the arcs, we divide them by 2. This one is more difficult because not only are they asking for an arc, they didn't give us, we have 2 missing pieces. So step number 1, like Paxton said, subtract 102 from 180. It is. This is arc. The arc y is y. So we found the angle because these 2 are supplementary. Those 2 are supplementary. So these are. So now that we found it, now we can go back to our formula page, put all the pieces where they need to be, and solve for y. I'm looking to see how many people look completely lost. I'm not sure. You're lost? Oh, okay.
Okay, so it's straight line. Put a line right here, and we got 102 right here. Okay? 180 minus 102. What do you get?
And then you
Thank
use
you.
that formula, and that's how you get the arc. Mine just,
Okay.
it just, why is it 95 plus 5?
These ones are crossing inside, so we use the adding formula.
Oh, weird rainbow.
Yep.
Number 5. Number 5.
Okay, let's look at number 5. Okay, these 2 are intersecting outside, so look at your formula sheet. How do we find missing parts when it's intersecting outside? What's different from that one? Yep, we are going to be subtracting instead of adding. So we're going to take A minus 44. I would not recommend distributing the half. You can, Bradley. You can distribute it. This one's better than the other one because this would become a 22. I would get rid of the 1/2 first. Jeremy, how do I get rid of the 1/2 first? Divide both sides by a half. I know you want that to be 15. It's not. Dividing by half is the same thing as multiplying by 2. I don't know if it's duh or not, but it's just true. Okay, I think you know how to finish that one now.
Plus 44.
Add the 44.
134.
This is not a theorem. Please do not write this one down. This is the theorem. This is just explaining what a circumscribed, I'm not saying that in the microphone. What a circumscribed, what a circumscribed angle is.
One of these times you're going to accidentally say it and not know you said it.
Oh, I've said things I should in the microphone. I have to re-record the whole thing. Delete, re-record. Okay. A circumscribed angle is an angle whose sides are both tangents. So we've got tangent, tangent. So this angle is called circumscribed. And we're using it for the next one.
What's the worst thing you said in the microphone?
Oh, I just yelled at a kid. And then I'm like I said his name. And I'm like, no, you can't post it on YouTube. Delete.
You taught a lesson in front of no kids.
Yeah.
That's so awkward. We should get stuff done.
Whenever I forget to record during class, I have to record it. So I just do it after school.
Why don't your kids come and just watch?
They can do it during class.
I usually just shut the door.
What if a teacher wants?
So I added something onto this one, and it made way more sense than the words that they said. These 2 angles they're talking about, the circumscribed angle and this central angle, are supplementary. Except I spell this word wrong all the time. Maybe that's not even right. Is that an E or an I? Is it supposed to be an E or an I? Paige, do you know? Well, that might be wrong too. Who were my spellers? It's right. Jose said it's right. It's an E here?
Yeah.
Hey, do you have a phone in here?
It's an E.
Okay. I must have memorized that word wrong. The measure of a circumscribed angle, so again, it's two tangents, is equal to 180 minus the central angle. We talked about central angles before spring break. I've tried to review them. So a central angle, this word central angle, the vertex is on the center of the circle. So do you see, when you add them up, they'll be 180. They are going to be supplementary. That's why this inverse works.
Are all central angles?
No, what it means is if you take the central angle and you take these endpoints and you draw tangents, these two together, so this one plus this one will be 180. I read it like that the first time too. Like if you stop at the end of that line, the measure of a circumscribed angle is equal to 180. That's not true. You have to keep reading. Minus the measure of the central angle. Phew. That's a lot of theorems. It's a Chromebook. You can go grab them. There are 2 examples, but if you guys want to be getting them and logging in. My last class has 0 minutes to do it. So this is better. Where do you guys get all those water bottles from? Did they sell them downstairs? Did they give them away? Oh, okay. Oh, okay.